How's everybody doing out there? Well, welcome to day 5 of Corona Online School. Today we're starting chapter 6, which is a discussion about fractions. So eventually we'll get to adding, subtracting, multiplying, and dividing, but today we're just going to focus on talking about fractions, some definitions of fractions, and things like that. So let's first kind of look at problem 1 here. It says to divide the square in half 5 different ways. And how do you know the line you drew cut the square in half? So there's obviously a bunch of different ways you can do this. So one, we could go kind of straight across that way. And we know that it divided it in half because if we were to calculate the area, like the area on the top and the area on the bottom would be the same, or at least they look the same. It's the same thing. We can try to divide this one up and down. We could go from one diagonal to another. You go the opposite diagonal. And so you may think that's it. You may think, oh, well, these are the only possibilities. So there are weird stuff you can do. Like, for example, I could do something like this, where I could kind of divide it with not a straight line, but like a little crooked line. And so if we divide it in such a way, then the two fractional parts should actually match up. All right, so in the next one, what we want to do is we want to divide this rectangle into 8 equal parts first, then shade one part. So when we're dividing it into 8 equal parts, and that means we want to draw 7 lines in our boxes, and you try to make them as evenly spaced as you can. So let's see, so I've got 1, 2, 3, 4, 5, 6, 7. So not too bad, they're pretty close. And then we want to shade one part, so it doesn't matter which one you shade, just shade one of them in. And if we were to write this as a fraction, so we've got one shaded part over 8 total parts, so our fraction in that case would be 1/8. All right, so let's look at 3 real quick. So for 3, Denise shaded 4 pieces of paper with a gray crayon. Which piece of paper is 3/4 shaded? So use what you know about fractions to explain why your answer is correct. So first off, we could definitely rule out B for multiple reasons, but one, only one part is actually shaded. So notice another problem with B is when we're talking about fractions and we try to divide things up, they need to be divided up evenly. So notice we've got 2 kind of big rectangles and 2 small rectangles. So that's no good. So D, even though D has 3 blocks shaded, again, they're not divided up evenly, so that eliminates D as well. So A and C both have nice evenly divided rectangles, but the only one that has 3 of them shaded would be C in this case. So C looks like the right answer for 3. And then for 4, we've got a couple different models. So we've got a chocolate bar where 3 of them are kind of taken away. So in this case, if we wanted to write a fraction for the chocolate bar that was eaten, so 3 pieces were eaten, and how many pieces were there total? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you do want to count the ones that were eaten as part of the total because they were there originally. So 3/10 of the chocolate bar was eaten. So in this case, of the girls that like chocolate ice cream, so we've got 2 that are circled. So those are the ones that like chocolate ice cream. And how many girls are there total? So it looks like 3. So 2/3 of the girls like chocolate ice cream. And then finally, blank of a cup of water is needed for the recipe. So it looks like to me, it looks like it's about half full. So I would say they used a half of a cup of water for the recipe. All right. Any questions or anything about page 1? Perfect. All right. So page 2. So in this case, it's a bunch of definitions. So I've got a PowerPoint on the team site. So go there, write down the definitions and stuff, so that way you don't have to worry about me boring you with the video with them. But if you have questions about them, feel free to ask. So instead, let's move on to number 1 here. So there's a bunch of these that are similar. So I'm going to do number 1. I'm going to let you guys do the next couple. So you've got use 1/6 to complete the following. So it asks us a bunch of questions. So first, write the fraction in words. So in this case, we write this as 1/6 in words. So model the fraction as a part of a group or a set. So if we were thinking of this in terms of a set, what we'd want to do is we'd want to have kind of like a rectangle with some dots in it. And so what we want is we want to have enough dots to represent the bottom number. So there's 6 things total, but of those 6 things, we're only choosing one of them. So in this case, by circling just one of them would represent the fraction 1 out of 6 in that case. All right. So when they say model it as part of a whole object, so in that case what we're going to do is use kind of the rectangle model like we did on the first page. So we first want to divide this up into 6 equal units, so we need 5 lines, so 1, 2, 3, 4, 5. And so again, we're interested in just shading one of them. So if I shade one of those guys in, that would represent 1 out of 6. All right, good. So what does the denominator represent? So this is going to be true in general. So it's how the whole object is divided up. So in this case, our whole object, whether it's a piece of pizza, a cake, pie, whatever it happens to be, is divided up into 6 slices. So in this case, the denominator always tells us how many slices or how many pieces are in the whole. And then what the top number represents is how many is chosen from the whole. So in this case, if we were thinking about it in terms of pizzas, we'd have a pizza that had 6 slices and there was 1 slice remaining, is kind of the idea. So what kind of fraction is 1 over 6? So this would be a unit fraction because it's got a 1 on the top in this case. So it's also a proper fraction technically, but more precisely it's a unit fraction. So now I put 1/6 on a properly marked and labeled number line. So in this case, I'm going to give myself some room, and so I'm just going to go the whole way out from 0 to 1. And so the idea is I want to mark these tick marks off in such a way that it's easy to label 1/6. So for example, I wouldn't want to just divide this in half and then try to estimate what 1/6 is, because I can determine what the labels are going to be. So in this case, what I want to do is sort of the same thing we did with the rectangle up above. I want to divide this guy into 5 evenly spaced tick marks. So again, I'm going to try to do my best here. So 2, 3, 4, 5. So it got a little worse as we went along, but imagine they were equally spaced. So in this case, this would represent 1/6, 2/6, 3/6, 4/6, and 5/6. So on our number line, where we want to mark 1/6 would be that very first line that we made. So that would give us that dot. All right. So you guys try 2, 3, 4, and 5 on your own. So again, if you have questions about any of those, definitely ask. I think based on what I did with the first one, you should be able to follow through and do the rest of those. So let's look at number 6 real quick. So 6 talks about how to place different numbers on a properly marked number line. So we've got 1/4, 4 over 4, and 4 over 1. So in this case, we want to make sure we give ourselves enough room because 4 over 1 is a big number. So we're going to have to go far enough up to get that. So let's do 0, 1, 2, 3, and 4. So 2 of these we can mark right away because 4 over 1 we know is the same thing as just 4. So that's going to give us that guy. And so technically 4 over 4, hopefully you recognize, is the same thing as 1. So that means we can mark 1 there. So the only one that's a little bit trickier is the 1/4. So again, what we have to do is we have to kind of subdivide our interval from 0 to 1. Since we want this to be in fourths, if we were doing this with a number line or a rectangle, we'd have to divide it into 3 pieces. So in this case, we want to do the same thing. So we want to get 1, 2, 3 lines in there. So it's 4 pieces, 3 lines. And so 1/4 would just be the very first line that we came to. And so we'd end up with that number there. So that's what it would look like on our number line. So again, if you have questions or anything like that, just let me know. All right, so now what we want to do is kind of go back and forth between writing improper fractions as mixed numbers and then mixed numbers as improper fractions. So you may remember this from another class, but if not, I'll kind of go through and show you how to do this. So if we want to write an improper fraction as a mixed number, what we have to do is divide. And so I'm going to do A for each of these, and I'll let you guys do B. So anytime we're doing this conversion, if it happens to be a negative, just ignore the negative until the very end. We know our answer is going to be negative, but with the calculations, kind of pretend the negative's not actually there. So if I'm doing negative 15/4, what I want to do is divide 4 into 15. So 4 goes into 15 3 times. Gives me a 12 with a 3 remainder. So in this case, my number that's on top is going to be my big number of the mixed number. My remainder is going to go in the top of my fraction, and the part that we're dividing by is always going to be our denominator. So in this case, 15/4 would be 3 3/4, but since it was a negative, we're going to write it as negative 3 3/4. So again, you guys do 19/3, make sure you know how to do that. If you have questions, just let me know. So for 8, if we're going backwards and we're trying to turn a mixed number into an improper fraction, so what we want to do is actually multiply the denominator by the whole number part and then add the number of pieces we had left over, the top number. So in this case, we're going to get 7 times 4 is 28, and then plus 6 gives us 34. So our new top number is going to be 34, and our bottom number just stays the same, 34/7. All right. So again, you guys do B, ignore the negative until the very end, like just pretend it's 3 2/3, and then just tack the negative onto your answer. So don't let the negative scare you or anything like that. All right. Is that okay for number 7 and 8? All right, perfect. So let's take a look at number 9 here real quick. So again, we've got a number line with a lot of different things that we're trying to place on the number line. And so again, what we want to do is kind of mark our tick marks off in such a way that it's easy to graph what we're trying to graph. So in this case, I'm trying to graph 5/3, which is bigger than 1, technically. So I'm going to have to actually go past 1 on my tick marks. But since I've got a 3 denominator, then that means I want to make 3 spaces, but I want to use just 2 lines to make those spaces. So in this case, I'm going to divide 0 to 1 up into 2 tick marks. So this would be like 1/3, 2/3, and then technically 1 would be 3/3. But then since I want 5/3, I've got to keep going and kind of come down on this side. Let's assume that's 2. So let's again divide this up into thirds. So this will be 4/3, 5/3. So there's the answer I'm looking for. So there's where 5/3 would live on that number line. All right, so let me do the next one also, and then I'll let you do the rest, just because this one's kind of a weird one, because instead of going 0 to 1, it's going 0 to 3/2. So in this case, since this is going to 3/2, remember this is the same thing as like 1 1/2. And so I'm actually trying to figure out where 1 would live in this area. So what I want to do is I want to kind of divide this guy up into 3 spots. So I'd want to divide this up into 1/2, 2/2. Oops, did that wrong. Hold on, let me start over. See, we all can make mistakes. So in this case, I'm trying to get 3/2, so I need to get 2 tick marks in this spot. So I'm almost like dividing that up into thirds. in this case. So even though my denominator is 2, because I'm past the 1, I still need to divide it up into thirds. So this would be my 1/2, this would be my 2/2, this would be my 3/2, but 2/2 is the same thing as 1. So there would be the answer that I'm looking for that guy. So number 1 would look like right there on the number line. All right, so again, try the rest of those on your own. We'll see how you do. And so now let's take a look at number 10. So how can you tell if a fraction is close to 1? So this one I would kind of ask everybody in class. Unfortunately, we can't yell back answers at the moment. But what we're looking for is when the numerator and the denominator are almost the same number. And so same thing for 1/2. When something's close to 1/2, the numerator and the denominator would be kind of about halfway in the middle. So and if you're close to 0, then that means that our numerator is really close to 0, really small. All right, so with that in mind, 11 asks us to list 2 fractions in each box using 9 as the denominator. So in this case, if I want something close to 0, and I've got a 9 as a denominator, then I'd want to pick things pretty much as small as possible. So like 1/9, 2/9, things like that, because those are going to be really small and they're going to be closer to 0. If I want to get close to 1, so I'm going to skip the middle for now, then I'd want to be as close to 9 as possible. So in this case, like 7/9, 8/9, both of those guys are going to be really, really close to 1. And so when I'm close to 1/2, so I'm looking for things that would be approximately 1/2 or so. So in this case, 4/9 is going to be a little bit smaller than 1/2. 5/9 would be a little bit bigger than 1/2 in that case. So this would be a nice, easy way to kind of break these guys down into which ones are close to 0, which ones are close to 1, which ones are close to 1/2. All right. Any questions or anything about that? All right, perfect. All right, so now let's look at number 12 here. So again, we're kind of doing the same thing, but what we're doing is we're trying to pick a number that's going to give us something that's close to 1/2 but less. And then for 13, we're doing the same thing, close to 1 but less than 1. So in this case, if I looked at 12a, 50/100 would actually give me exactly 1/2. So if I wanted to be close to 1/2 but a little bit less, so I'd want to choose something like 49 in that case. And so again, I'll let you kind of finish the rest of those guys. So for 13, we want to get something that's close to 1 but less than 1. So for 13a, 27/27 would give us 1 exactly. So if I wanted something a little less, then I'd want to do something like 26/27. So again, I'll let you finish those guys out. But again, if you have questions about it, don't hesitate to ask. And so finally, yes, last page. So this was the big package. There's a lot of stuff going on. So in this case, it's saying use the number line to decide the areas that are closer to 0, closer to 1/2, closer to 1. So the way I usually like to think about this is, so if we divide this into the different pieces, so I've got my 1/2 in the middle. So we've got kind of a nice natural breaking point in between these guys, where if I look at 1/4 and 3/4, that gives us a nice kind of judge to see whether something's going to be closer to 0 or closer to 1. So the way I look at it is if it's somewhere between 0 and 1/4, I would say it gets closer to 0. If it's between 1/4 and 3/4, I should draw it underneath, then I would say that's closer to 1/2. And then if it's closer to 3/4 to 1, then I would say that's closer to 1 in that case. So again, using that, what we want to do is kind of decide where all these different fractions kind of live in the box below. So 15 I'm going to probably do like as our exit ticket or something like that. So I'm going to let you guys do 15 on your own. Again, use what we've kind of done as above as a model to decide which one would be closer to the other. If you have any questions or anything like that, post it to the team site, post it through Remind, and I'll see you guys tomorrow. Good job.